Hi, this is Elliot Fishman, and welcome to part 5 of our talk on cinematic rendering. And in this last part, we're going to talk about some areas where I think cinematic rendering can be going. One of them is with display. Regardless of the fact that it's 3D imaging, we still look on a display, just like we look at axial images. In the past, we've done some work with different types of displays, wearing different glasses, and the HoloLens is one of those things that's really hot in terms of the fact that HoloLens is being used across a range of different industries to better understand things in 3 dimensions. It gives you the depth and it gives you the ability to interact with the data using hand gestures. Now, I find it a little bit challenging personally, but I probably need to spend more time doing it, or I need to be 15 years old. 15-year-old kids can figure it out, and probably my grandchildren can figure it out very quickly as well. Here's an article we published about doing cinematic rendering with augmented reality, which is what you do with the HoloLens. Recent advantages in 3D visualization of volumetric CT have led to the novel technique of cinematic rendering, which provides photorealistic images. We talked about how we use the software, the interface, but also make the point that it's really cool, but to see if it's valuable, we're working on, and we need to work on, and other people need to work on some sort of clinical trials to see if it does make an impact. But I think when you use it, you know that it has to make an impact. With the cinematic rendered images projected into the augmented reality system, the user can make a brief squeezing motion with your hand, outline the image, a cube comes up, you then can manipulate the image, you could walk through the hologram, you can see obscured anatomy or pathology, and again, it takes a little bit of work and learning, and those of you who've tried augmented reality know it's not as simple as it seems, particularly if you want to really control the image, but I think it's doable. There are other potential advantages of the combination of cinematic and augmented reality. And again, with AI coming along, perhaps AI will be driving a lot of this process. And there are many companies that are working on augmented reality, whether it's Apple, whether it's Google, whether it's Facebook, whether it's Siemens or GE, all sorts of companies know it potentially can have an impact in the future. The question is, when is it going to be there, and when will it be more than something that's super cool and has lots of potential to becoming standard of care? Here are some images I shot when I was working on this case, where you can see very nicely celiac and SMA, and replace right hepatic off the SMA. You can see in the top of the image, that's the lights in the ceiling, because when you're looking at these images, they're sitting in the air. So I was working in my lab, so the images are literally sitting in space, and you're moving them around. You can see there's my hand. I took a picture of my hand in the picture, and my hand is what's moving the images. I do admit personally it might be good if I had some sort of stylus or had a flat board to use to move the images around. It might be easier for me, but again, I think it's a learning process. Here's another example showing you the liver, showing you the portal vein and SMV, and now I'm simply going to use my hand to rotate the images and look inside, get around the images, move around, go from above, and again, we're using cinematic rendered images as our input. So people have used axial images, we're going with cinematic rendered images, so really seems exciting in that regard. Here's an example of cardiac imaging, looking at the pulmonary vasculature. You can see again, it's projected against the cabinets in my office. So it's good to do it, I've learned, against a clear wall. So when you take pictures, at least you don't see a whole lot of what's going on. But look at the detail of the coronaries, look at the detail of the pulmonary vasculature and the lung parenchyma. And there's been work that's been done. This article by Perkins in the Annals of Thoracic Surgery, mixed reality visualization during surgical planning may facilitate accurate and rapid identification of small lung lesions during minimally invasive surgical procedures and reduce the need for additional invasive preoperative localization procedures. So This is really talking about using augmented reality in the surgical suite. And there's been work done there. Here's an article about liver surgery. The initial experience suggested that an intraoperative hologram with mixed reality techniques contributed to last-minute simulation, not for navigation. The interoperative hologram might be a new next-generation operation supportive tool in terms of spatial awareness, sharing, and simplicity. Again, lots of potential, and we'll have to see where this goes. In this article by Beams, makes the point a number of potential avenues currently being explored would create the needed platforms for collaboration, including proposals to further the research, establishing partnerships among industry, academia, and regulators. Again, it is going to take time. We'll see what happens. I spoke in the beginning of this talk in part 1 about how long it's taken 3D to be moving along and still hasn't become routine practice. Imagine something like augmented reality. But again, what happens in the gaming world, what happens outside of medicine, often will drive the speed of what happens in medicine. And again, we're going to have to see really where this fits in. Again, that article by Beams, different surgical tasks have varying requirements for AR image accuracy, which can influence device design. So I think it will take time and things will need to change, but I think it's something we need to get involved with now and really think about what we can possibly do. In this article by Elshaw, Comparison of Cinematic Rendering and Computed Tomography for Speed and Comprehension of Surgical Anatomy, they made the point that when you use this technique, you're able to see things better. A more photorealistic visualization may facilitate image interpretation and improve the comprehension of surgical anatomy. So now we're going into another part. When we talk about using cinematic rendering in surgery, we always talk about surgical planning, interoperative thinking, but what about just learning? I think one of the easiest things of cinematic rendering and one of the easiest touch points that will work for augmented reality is just education. Okay? Learning anatomy, learning it in the volume, it's a lot better than learning it in the pictures or learning off static slices. Cinematic rendering may assist surgeons with preoperative preparation and intraoperative guidance, but it's the learning process. And we did some work with this, and I'll just share some examples. Teaching the lung. This is an app we have on the Apple Store using cinematic rendering to be able to teach you anatomy of the airways, teach you the anatomy of the muscles. Again, having things disappear so you can see more detail, the costochondral junctions, looking at the bony structures, then looking at the vascular structures, the ability to just have one data set and have things disappear and learn relationships. It's hard to do better than that. Just looking at a skeleton in your hand or looking at some pictures in a book, no way is it as good as doing like this. Now, no one has really shown that with numbers, but perhaps we should. Here's another example. Looking at the patient's heart, you can see the individual coronary arteries, the individual chambers. But again, with cinematic, I can make things disappear. I could rotate things around, follow how the left coronary artery or right coronary artery tracks, relationship of coronary artery to aortic valve, the chambers, looking at things from different angles. So again, and imagine this with a augmented reality display. This we're doing is without augmented reality, but look at the detail, and that's the app. You can take a look at it. I think you will enjoy it. Now, next steps. Some things I've thought about. What if you made a topogram from cinematic rendering? You'd have really good detail of where things are, where the lines are in relationship to muscle. Again, the importance of AI. Everything we do can be improved by AI, and I think it will be. And then the merging of cinematic data, which we talk, when we say cinematic data, we're always talking about CT, but perhaps what about with PET scan or other functional data? And Philippe Sawyer makes the point that cinematic rendering is really where things are going. Preliminary work shows that cinematic rendering produces photorealistic images with enhanced detail by comparison with other rendering techniques. Now, in my mind, for cinematic rendering to prosper, we need to get away from pretty pictures to data. Clinical studies that measure outcomes with or without CR will be critical. More clarity into the variability of image quality and its impact on clinical utility. Clinical studies comparing radiologist accuracy with or without cinematic rendering or surgical planning with or without cinematic rendering becomes critical. And again, clinical studies focusing on the end user, showing the true impact of our studies and whether we can improve things in that regard as well. Now, I mentioned the idea about PET CT, and we did publish a few articles recently. Cinematic rendering of PET CT provides a photorealistic means of visualizing complex fusion imaging datasets. And that indeed can prove to be very exciting. Here's some nice examples of cinematic rendering of the CT PET studies showing you the uptake in normal structures as well as the patient's tumor involving nodes in the pelvis and the ability to visualize this. Now, it's going to be somewhat challenging. You need to create different light maps, different renderings. I've developed a lot of presets I showed you for pancreas, liver, kidneys, bowel, everything. I don't have a good set of presets yet for looking at multimodality data sets, but I think it's something we need to do. The ability to use lighting models to enhance various structures within the PET and CT data sets will indeed become very, very important. There are limitations to our technique. Again, it takes time. Until we get good at it, it's going to take more time. But I think when you talk about directions and opportunities, the ability to use multimodality data sets in a display like cinematic will indeed prove to be ideal both for the radiologists and referring physicians, be it surgeons or oncologists. So again, future directions. This last talk really touched on new things. I mentioned AI a bit, AI optimizing the visualization, and then AI to help detect the lesions, and we're doing that with AI. We're working with Microsoft for looking at early pancreatic tumors. The visualization techniques like HoloLens. Can we have HoloLens where you have multiple users to go over the case together? It's something that's coming along. And we need more tools to optimize image quality, including the lighting models. It all takes time, but future directions, the future seems bright. And yes, what's nice about these HoloLens 2 is I can still wear my glasses. HoloLens 1, I had to take my glasses off because it would squish your glasses otherwise. So we are making things a bit easier for people like me. Now, it's interesting, I showed you that the first articles on cinematic rendering were 2016. That's about 7 years. And yesterday when I got the latest update from the PubMed on cinematic rendering, there was only 139 articles. Now, what's a problem, that's not many, because that's multiple years. You can see the chart, but a lot of them, particularly recently, are simply case reports or an article that talks about advances in musculoskeletal imaging, and there's one picture of cinematic rendering, and it shows up in the PubMed search. So I think more work needs to be done in the published literature to really make it possible. So I think with that, it's very exciting. Hopefully this series of talks will help you and help you get started. And remember, there's no better time to get started than today. And with that, I thank you for your attention and have a great day. If you like this video, make sure to subscribe to the CTisus YouTube channel. You can also visit us at CTisus.com for even more videos, plus quizzes, pearls, protocols, and oh so much more. We're also in the App Store and have well over a dozen apps for iPhone and iPad, all completely free. Thanks for watching.